Hello. We've gone through the theory of the SIFT operator, and I thought it would be useful just to look at a few examples in a little bit more detail. So here's a well-known example involving some mountain peaks. And I've got a pair of images. They're not identical images, but they do overlap. And you could use, for example, a pair of images like this for doing image stitching if you knew what the corresponding features were between the two images, so you knew how to align them. And this is where the SIFT operator can come in. I mean, I think you'll have to look at the images in detail. You probably can't see the features very well in the video, but if you look at the images in detail from the notes, you'll see that the feature points, say here at the top of this peak, there's sort of a little group of 3 right here that are all more or less in the same position on the peak and the same alignment sort of right here. Here's another little bunch of features right here at the top of this little peak. Here's another little group of features right here. There's about sort of 4 or 5 that sort of are in the same position right here. Here's another nice little obvious one in a little dark spot between the two images. So this gives you kind of idea that although the two images are different, the SIFT operator has identified a similar kind of image location, the extremal point in the two images, and one hopes in order to do the matching that the local descriptors are also the same. And that seems pretty likely because as you can see from the image, the intensity patterns surrounding each of those points is also the same. And so that suggests that they ought to be matchable. Here's another image that we did ourselves. So taking a famous image of a famous scientist, we applied our SIFT operator to it, and you can see the little yellow arrows of where the SIFT features are detected. As before with the house image, the base of the arrow is the position of the feature, the direction of the arrow is the orientation of the feature, and the length of the vector gives you some idea of the strength of that feature right here. And what we've done here is we've taken the original image and we've also shrunk it and also rotated it, and also translated it, and so you get some idea of the sort of the translation, rotation, and scale invariance type effect. And you can see some of the features are quite stable. So for example, this is one of the larger ones right here. You can see that over here. Similarly here on his forehead, there's one right there. There's a couple on his eye right there that are sort of stable and things like that. So you can look around the image. There are also a lot of features which are not stable, and therefore they are not the same between these two different images. But there's quite a fair number of them, and that's enough to give us some idea. Maybe we've correctly matched the object, or certainly established estimate the rotation and translation that transforms this image into that image. So what we can see from these examples is that the SIFT operator may give us quite a lot of points. Certainly in that mountain example that we saw in the very beginning, we do get quite a lot of feature points. But as it turns out, not all of these will be matchable, and that's sort of one of the standard observations. If you applied this to a typical image, you might get 1,000 or 2,000 SIFT points, but only a few hundred of these might be matchable if you used it in a stereo pair. But fortunately, a few hundred matched points is quite enough for doing your stereotype calculation. From the little example with the picture of Einstein, we could see how the translation, rotation, and scale invariance seems to have worked okay for a large number of those feature points. Also, another sort of thing, if we go back to this image itself, you'll see that there are these feature points, and they are stable and they are invariant, but you might say, well, what do they correspond to? And well, if you sort of look, here, you can't really see anything in the intensity image that really tells you that that's exactly what it is. And that's one of the, I guess, sort of little mysteries about the SIFT operator. It sort of works and it picks out usable features, but they don't always necessarily make sense to a human. But that doesn't really matter. Our algorithms can work just fine with that kind of level of uncertainty. Thank you.